Hello viewers, welcome to CEC lectures. Myself Dr. Priti Jagwani. I am from Department of Computer Science, Aribhat College, University of Delhi. So in this present series of computer networks, the topic which we are presently studying is about medium access control sublayer protocols, and in my previous classes we have covered pure ALOHA in this category, and my today's topic is slotted ALOHA. So before going into the concept of slotted ALOHA, let us take a quick recap that in which particular category these protocols are going to fall, and what is about the pure ALOHA and how we are going to take care that concerns of pure ALOHA into today's topic, which is slotted ALOHA. So all these pure ALOHA, slotted ALOHA are types of random access protocol which falls under the category of multiple access protocols. So multiple access protocols here of basically three types: random access protocols, controlled access protocols, and channelization protocols. So random access protocol, when we talk about basically all these stations on a particular network have equal priority of transmission of sending the packets or of sending the communication, and transmission decisions are based on the state of the channel, whether the channel is idle or busy. Considering the features of random access protocols, as I am saying, these are random access. There is no fixed order of transmission and similarly no fixed time slot assignment. So the four random access protocols which we are going to cover in this series are ALOHA. Then the two versions of ALOHA are obviously there: pure ALOHA, slotted ALOHA. Then we have SASMA, CSMA, carrier sense multiple access. Then carrier sense multiple access with collision detection, which is SASMA CD, and carrier sense multiple access with collision avoidance, which is SASMA CA. All these four random access protocol we are going to cover. Looking into quick recap of ALOHA, which is designed for wireless LANs and shared media. Multiple stations can transmit simultaneously, and this feature is going to lead to the collision, and it is actually a packet switching system where the time interval which is required to transmit one packet is called slot, and pure ALOHA is a random access technique. In pure ALOHA, a station transmits a frame whenever it has a data to send. So, and obviously with this property on a shared channel, there is always a risk of collision between the frames from different stations. Acknowledgement is obviously is a key property here, where receiver responds with an ACK if ACK is an acknowledgement if the frame is received correctly. In order to handle the collision, if no acknowledgement is received, the sender is going to assume that a collision has occurred, and before retransmitting, the sender waits for a random back-off time to reduce the chances of repeated collision. But even with this random access and an uncoordinated transmission, your pure ALOHA protocol, there are high chances of collision, and there is kind of a vulnerable time in pure ALOHA, which is kind of very large, and that is equals to 2 into T2 TP, where TP is the transmission propagation time, and if another transmission is starts within this period of 2 into TP, both the packets will be destroyed. So now moving on to kind of slotted ALOHA, one point here, that if we calculate the efficiency of pure ALOHA, that comes to 18.4% only, and that is equals to 0.5 into e to the power minus 1, and then that maximum throughput comes to 18.4%. Now within this means that only 18.4% of the channel capacity is effectively used for successful transmission, while the rest is wasted due to collision. Now moving further, this is actually what we can say is kind of a very we can say less throughput, although this pure ALOHA is very simple to implement, but the efficiency is very low. and obviously there is a high probability of collision under the heavy traffic. So that means this protocol is certainly unsuitable for real time applications which require guaranteed delivery. So then the next question comes up, what is the solution? The solution is slotted ALOHA. So when pure ALOHA has a very high chance of hitting a frame, then slotted ALOHA is basically intended to outperform its efficiency. That means the efficiency of pure ALOHA. In slotted ALOHA, the shared channel is split into some fixed time intervals, and these fixed time intervals are known as slot. As a result of this slotting mechanism, if a station wants to send a frame onto a shared channel, it can only do so at the start of a particular slot, and only one frame can be sent to each slot. That means in one slot multiple frames cannot be sent, and in the middle of an outgoing in the middle of a current slot or at the end of the slot, no one can send the packet. It is only at the start of the slot. Additionally, these stations must wait until the beginning of the slot for the subsequent transmission if they are unable to transfer the data at the beginning of the slot. So that means if a station is going to miss the slot, that means that station will definitely wait until the beginning of the next slot. However, sending a frame at the start of two or more sending a frame by the at the start of a slot by two or more stations, it still carries the risk of a collision. So that means although this slotted ALOHA is going to outperform the efficiency of pure ALOHA, we cannot say that the collision is not going to happen, or collisions are collisions will not happen in slotted ALOHA. So this slotted ALOHA, when we look into the history, it was brought into 1972, obviously as an improvement to pure ALOHA, and the time in case of slotted ALOHA is divided into, as I have told you, it is divided into discrete intervals called slots that corresponds to a frame. And here slotted ALOHA overcomes the possibility of a frame hitting in pure ALOHA. Unlike pure ALOHA, this type of ALOHA does not allow transmission whenever the station wants to send it. As I have already told you that the transmission can only begin at the beginning of the slot. So if a station wants to send the frame to onto a shared channel, it can be only sent at the beginning of the slot. Only one frame is allowed to be sent to every slot, and in case any station wants to send but fails to send the data, it will have to wait till the next slot. But despite of all these cautious measures, there is still a possibility of collision in case two stations try to send the frames at the start of a particular time. So let us see how this slotted ALOHA work. What is the key mechanism? So time slot is one of the important kind of characteristics of slotted ALOHA. Then there is synchronization. Synchronization as in all the nodes are synchronized to these slots. So that means now with this synchronization we need to be careful that clock synchronization is kind of an extra thing which is required in case of a slotted ALOHA, and which was not required obviously in pure ALOHA. A node that wants to transmit must wait for the beginning of the next time slot. The node sends the frame at the start of the time slot, and obviously there is a mechanism of acknowledgement. If the frame is received correctly, the receiver sends an acknowledgement. Now what about collision handling? So collision is bound to happen even in slotted ALOHA despite of so many cautious measures I have already told you. If multiple nodes transmit in the same slot, a collision occurs and all the frames which are collided will be kind of, we can say, destroyed. After a collision, the node nodes wait for a random backoff period before retransmitting to avoid the repeated collision, and every station here will kind of wait for a random backoff period. That backoff period is, we can say it is not a fixed backoff period. So what will happen if it is a fixed backoff period? So if it is a fixed backoff period, again in the next slot or again in the next cycle, the collision will happen, and we will keep on the frames will keep on colliding always. So here is a figure which will give you idea about the kind of different slots and how the transmission happens in case of slotted ALOHA. So let us try to understand this figure first. So here, as you can see, that there are 4 stations in the figure, and all these 4 stations are sending some kind of packets at some point of time, and these packets are actually shown with the help of a rectangle, and the timeline here is, or we can say the transmission line is shown in the horizontal direction. So along the transmission line, and if you can observe the marking on this transmission line, this marking is actually nothing but the slots. So if you can see here, station 1 is transmitting some packets, and these packets are kind of, we can say, successfully sent. But when we look into kind of station 2, after some random transmission delay, if that station 2 is kind of transmitting some packet, and please in the figure observe station number 4. Station number 4 is also sending some packets at the same point of time when your station 2 is sending. Then what will happen? Definitely these packets which are sent by station number 2 and station number 4 are bound to collide. So these are, we can say, colliding packets. Stations 3, however, seems in kind of some of the we can say in a safe situation, because on the transmission line or on the timeline of transmission, the packet sent by station 3 is not kind of matching with any slots of station, either of the station 2 or of station 4 or maybe of station 3. So station 3 is kind of in a safer situation, and all the packets sent by station 3 are safely being transmitted. Station 4, however, is in a colliding mode, and as I have told you that when the packet from any particular stations are colliding, then all the frames or all the packets will be destroyed, and then both the stations or all the colliding stations will definitely wait for some random backoff period, and for after that random backoff period they will retransmit their packets. That is what the whole procedure is, which is shown in this figure. Now after understanding this figure, let us move on to the further details of this slotted ALOHA protocol. So this was actually we can say the key mechanism how this slotted ALOHA is going to work. Moving further, we look into what are the applications of slotted ALOHA. Although nowadays there are so many other efficient protocols which are available. Why I am saying efficient? Because again the efficiency or the throughput of this slotted ALOHA is not very impressive. So we can say in modern large scale networks, slotted ALOHA is kind of rarely used, because there are other mechanisms or other protocols, more efficient protocols which are available. But this slotted ALOHA is still applied in some kind of satellite communication systems, some wireless networks, RFID tag communication systems, and as a foundation of our next upcoming topic, which is SASMA protocols, and these SASMA protocols are used in Ethernet and Wi-Fi. So this SASMA is carrier sense multiple access, and this slotted ALOHA serves as the foundation for these SASMA protocols, also used in satellite communication systems, wireless sensor networks, and RFID tag communication systems. Now, as in pure ALOHA, we looked into the throughput. Here also we are going to look into the throughput, which is the rate of successful transmission per slot, and this is going to be given by this is denoted by the term S, and this is equals to S is equals to G into e to the power minus G, where S, as I have told you, is the throughput, G is the offered load, in the sense average number of packet transmissions per slot. Then maximum throughput occurs at, obviously G is equals to 1, and when we put the value of G as 1 in this formula, that is S is equals to G into e to the power minus of G, and how this formula has arrived, that we have seen in pure ALOHA. So, our S max, which is the maximum throughput in case of slotted ALOHA, comes to 1 upon E, which is nothing but 0.368. So, 0.368 means 36.8, which is, we can say, is precisely the twice as efficient as pure ALOHA is. Please recall the efficiency of pure ALOHA. It was 18.4%, and when we double that, we are going to get the efficiency, or we can say the maximum throughput of slotted ALOHA, which is 36.8 percentage. So that means your slotted ALOHA is twice as efficient as your pure ALOHA was. So yeah, great. That means we have kind of doubled the efficiency, but again this 36.8% efficiency is something which is not, as I have told you, which is not very impressive. So that means we need to look into more more number of protocols or more efficient protocols, and in any case this slotted ALOHA is actually an old protocol, as I have told you that this was introduced in 1972. So from 1972 to till date, so many other protocols have been developed. Also, there are some assumptions of the slotted ALOHA under which this protocol is going to work. So, definitely we need to look into what are the assumptions of this slotted ALOHA. So, let us look into these assumptions. So, the first assumption says that all the frames are of equal size. We have not considered varying sizes of different frames. Then time is divided into slots equals to 1 frame time. So, timing, or we can say the duration of the slot, is also kind of fixed, which is equals to 1 frame time. Then assumption is that nodes will be able to transmit only at the beginning of the slot. This we have seen in our key mechanism also. Then all the nodes are synchronized to the slot boundaries. Then also then only it is possible that node transmits only at the beginning of the slots. So that means these two assumptions, that node transmit only at the beginning of the slots and all nodes are synchronized to the slot boundaries, are kind of, we can say, tied to each other. Also collision can be detected within this slot duration. So these are the assumptions of slotted ALOHA under which this protocol this protocol works. What are the advantages? If we try to look into the advantages and disadvantages of this slotted ALOHA protocol. So advantages says higher efficiency, or more specifically I can say higher efficiency with respect to pure ALOHA, with relative to pure ALOHA, because we have seen that maximum throughput of 36.8% is achieved, which is, yes, I agree, is double that of pure ALOHA, but it is it has a lot more room for improvement. Then implementation is simple, easy to design for the systems with moderate traffic, and this can be kind of easily programmed using any standard programming language like C++ or something of that sort. Then we have better collision control. Again, this is relative to your pure ALOHA, because synchronization reduces the collision probability, or we can say kind of reduces the probability of collision to a considerable amount, but obviously it is not going to remove the prospects or remove the probability of collision altogether. Then low overhead as compared to some complex or high end protocols, because it does not require any heavy coordination or complex mechanism which we are going to observe in our kind of upcoming protocols. So low overhead as compared to the complex protocols, higher efficiency and better collision control as compared to your the previous one, which is the pure ALOHA. Then these were the advantages of slotted ALOHA. Moving one step further, we also need to look into the disadvantages. Some amount of synchronization is required, because all the transmitting stations are tied to the slot boundaries, as I have told you. That means this requires clock synchronization among nodes. That much of synchronization is definitely required, so that this slot is going to we can say begin for all these stations at one particular one particular time. Then it is not free of collisions. Collisions still occur if two or more devices transmit in the same slot. No one can avoid collision, at least in case of this slotted ALOHA. Then throughput, as I have already told you, is low as compared to modern and complex protocol. Even at the best, efficiency which we are going to get with slotted ALOHA is 36.8%. Further, there is an increased delay in the sense that nodes must wait until the next slot to transmit, because in the middle of an ongoing slot, nodes are not allowed to transmit. So they must wait until the next slot to transmit, and this will definitely cause the extra delay as compared to pure ALOHA, because in pure ALOHA there was no kind of fixed amount of kind of back off period or fixed amount of waiting period, we can say. After waiting for random amount of time, your nodes were ready to kind of send send their packets or send their frames again. But here nodes must wait until the next slot of the transmission begins, and this will definitely cause extra delay as compared to your pure ALOHA. So in this lecture, what we have looked into is we have taken a quick recap of all the multiple access protocols and ALOHA with its limited efficiency considerations. We moved into the topic of slotted ALOHA. We looked into the key mechanism of slotted ALOHA. Then how it works, what is going to be the maximum throughput, and apart from that, what are the assumptions, advantages and disadvantages of slotted ALOHA. That also we looked into this lecture. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I'll see you in the next. Till then, take care. Goodbye.